Okay, everybody, welcome to the video on graphing quantitative data in a specific type of graph called histograms. So last class we talked about describing distributions, and we looked at graphs that were made, and we looked at dot plots, but a lot of times when we do categorical data, things don't fall neatly into dot plots. You know, if we have continuous as opposed to discrete data, when we look at it, then everything, decimals and everything, you can't put them on dots, and so we need some other way to organize them. And to do that, we're going to use what's known as a histogram. So how do we make a histogram? We're going to take the data and we're going to divide it into bins. Just think about like little bins, and we're going to, or if it helps, little tubes. Think of them as clear tubes. And then we're just going to drop rocks into the clear tubes, and they're going to stack up. You'll see what I mean in a second. So what we're going to do is we're going to divide our entire data into bins, or they say classes. I'll use the word bins. And we're going to drop any value that falls in that range into that bin. And then, of course, we're going to label and label the axes, label and scale your axes always. And the bars should touch. You'll remember that in bar charts, the bars did not touch. So in categorical data, the bars do not touch because blue doesn't blend into red. But here the bars touch because where one bin stops, the next bin will start. And I know this is a lot of theory, so let's get right into it and look at one. So we're going to make a histogram. So they went around, and in all 50 states, they calculated what percent of people in that state were born outside the United States of America. And then they looked at it, and they got a different value for every state. So there's no way they could make a dot plot, because one state was 2.3 and one state was 3.1, and then there's a state that was 3.7. You can't do that. So what they did instead is they counted up the number of states that had the percentage of people born outside the U.S. from 0 to 5. And they counted that there was 20. And then they went from 5 to 10, from 10 to less 15, 15 to 20, 20 to 25, and 25 to 30. And see how this is less than. So if a value had come out at exactly 15, you'd put it in this bin. If it came out as 14.99, you'd put it in this bin. And they did all 50 states. Now that table, while giving us good information, is really hard to visualize. And so what we do is we make a histogram. And so here is the bin, here is that class that's 0 to 5. And there were 20, so the bar goes up to 20. And then 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. And this axis is the counts. And they're just, each one is going to be a rectangle. And this gives us a distribution that then we could describe. We could describe the shape, the center, the spread, the unusual values if we needed to. But now we have a distribution that can be described. So let's make our own histogram here. First thing, when you make the histogram, is you got to figure out bin width. What are the bins going to be? In this last one, we went 5 percentage points each time. You're going to have to figure out, you should always have at least 5 bins. And if you have a lot of data, then you can have more bins. And a loose guess is, I've seen this used before, the square root of the number of data sets. But if you, minimum of 5. So if you had 104 data points, then you could have up to 12 bins. So here is the data set. Over the course of the season, in an NBA season, what are there, like, I don't even know, there are like 82 games in basketball, 80 games, I'm not sure. But they took how many points each team scored per game. And some teams had just rotten offense, and some teams had amazing offense. So in order to create a histogram, the first thing we're going to need to figure out is what is the lowest value. And the lowest value was 92.4. And they couldn't score a point to save their butt. Well, right below them, we have the Phoenix Suns, whose entire offense was run and gun and trying to get off a shot in 7 seconds or less. And that was 110.2. So where our bins need to cover every value between 90 and 92, and we need to have at least 5. And so you got to play with this a little bit. You got to look at numbers that make sense. So what's going to make sense? Well, we can have a bin from 90 to less than 95, and then a bin from 95 to less than 100, and then from 100 to less than 105, and then 105 to less than 110, and then 110 to 115. And then our bins are all equal width. We are going to have one value over the 110. It's 110.2, and we'll talk about this in class. We'll talk about next class about how when we change our bins, the shape of the distribution can change and how we have to be careful with how we shape our bins. So now we got to count. Now I went ahead and put them in order for you here. So from 90 to 95, there are 1, 2, 3, 4, 5. Oh, sorry. From 90 to 95, there are 1, 2. From 95 to 100, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, it's less than 100, so 100 falls in this next bin. So in the next bin, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then from, sorry, I stopped counting early. 14, 15, there's 15. And then in the next bin, there's going to be 2, and in the last bin, there's 1. So then we take our counts, 2, 10, 15, 2, and 1, and then we just make our histogram. And we already got our graph paper, and we set out, and this axis is this is points per game of NBA teams in whatever season, and this one is counts. And so we would just go 2, 10, 15, 2, and 1. And then, sorry, this not straight line is going to bug me. And there's our histogram. And so we can see the shape, and you can see that most of the teams, it's centered around 100 and 105. Most of the teams score in this range. Very few teams score outside of the range of 95 to 105. There's only a few. And so now we can start to talk about the distribution. Now, in addition to doing the axis as counts, we can also do the axis as frequency. And to do the frequency, we just look at, hey, there's 30 NBA teams total. So the frequencies are to just divide the count by the total, and now everything's changed into a frequency. And so then we can do the exact same graph here. And so we would go to 0.66. We come up to 0.33, 0.5, 0.66, and 0.33. And so this axis is now frequency. This axis is still points per game of NBA teams. Now what you'll notice is even though we changed the scale here, the shape of the graph did not change. The axis changed, so this one's a little bit more stretched out than this one, but the shape itself is actually the same, whether we use frequency or counts. So some general rules on histograms. Do not confuse histograms and bar charts. bar charts are for categorical data. Histograms are for quantitative data. You cannot take a histogram and go back to data that then you can try and find an average of. This chart, you can't go from this chart and then try and recreate this data here. You can't do that. All it's describing the distribution. So do not try and go back from the graph to data. And if you're comparing data that has different number of observations, let's say we're going to try and compare the NBA team to some European basketball team. If that league didn't have the same number of teams as the NBA, then we wouldn't want to compare counts. We would only want to compare frequency. And here's the big rule for a histogram. It doesn't have to be pretty. It just has to be meaningful. All right, so we will see you next class. And we'll be making lots of these in class and messing with different bin widths.